Okay, D, the problem's starting to escalate now. Unfortunately, for some students, are looking at this and saying, I don't think it has anything to do with the prior example. And it would be unusual if it didn't, by the way. So it's a question with parts in it. You're assuming the parts have something to do with the past, by the way. But if you want to use the rational root theorem on it, which I would say it's not a bad idea, the rational root theorem, to look for a root, because it would make it easier if you found the rational root to it. But unfortunately, looking at it, the only possible rational roots would be plus or minus 1. I'll write this down. These are candidates, by the way. But unfortunately, neither one's going to work over here. One's not going to work, and minus 1's not going to work. So then I'm starting to think that maybe it has something to do with what we just did. So I want to go to the whiteboard, and I got to sort of like remind myself. But I got this over here, x4. And then it's going to be plus x cubed. And then you get minus 10x squared. And then you get plus x plus 1 is equal to 0. All right? So what are you looking for? I'm looking for these p's in the problem. I don't see them yet, but I'm looking for these things over here. That's what I'm looking for. Now, the way I'm going to do it, and I don't know if it's going to happen, by the way, but I'm going to divide everything by x squared. I want to point out I know x is not a solution, x equals 0 is not a solutions problem, so x is not 0. And they said that from the beginning anyway, so I don't have to worry about that. But I want to point out this is a polynomial. 0 is definitely not a solution to that, all right? And you divide both sides by x squared. What do you get there? X squared. Then you get, let's see, x cubed divided by x squared is going to be x. This is going to be minus 10, a little disturbing there. Then you get plus 1 over x plus 1 over x squared. And 0 divided by x squared is going to be 0. I think I see something. I see x squared plus 1 over x squared. And then I see what else? I see plus x plus 1 over x equals 0. All right, I've seen these two before. And you might have to look back over your notes to figure this out, by the way. But I know this over here. Oh, I'm sorry, I forgot the 10. I got to get my eraser out again. Got to erase this business over here. Don't want to forget that, by the way. It's minus 10 equals 0. I'm going to say this part I definitely do recognize as P1. But again, if you have the paper in front of you where you just worked, and certainly I'm working at a whiteboard here. I think I erased that prior part, by the way. But I got it written down because I have my my prior work over here. And P2 is equal to P1 squared minus 2. And then we get this over here. I don't know if that helps. Let's put this down now. So P1 squared plus P1 minus 12 equals 0. Well, this looks like it might be factorable, but let's try that. So P1 looks like 4 and 3, and plus 4 minus 3. So I have solutions now. I'll tell you what they are. P1 could be equal to 3. That would make a zero product rule happen. And P1 minus 4. And that's connected by an OR, by the way. I also want to point out, this is a 4th degree polynomial. I'm expecting to see 4 solutions from the problem, by the way. Let's write down P1 again. What's P1 going to be? It's going to be x plus 1 over x equals 3. X plus 1 over x is equal to minus 4. And let's make some attempt to solve these guys over here. I'm going to clear the fraction by multiplying both sides by x. You get x squared plus 1 equals 3x. This gives me x squared minus 3x plus 1 equals 0. Let me clear the other one. You get x squared plus 1 equals minus 4x. X squared plus 4x plus 1 equals 0. Well, those two quadratics I can't factor using integer. So we can use a quadratic formula. What do you get? X equals, this is 2, 3 plus or minus 9 minus 4. We'll simplify that later. Or x is equal to 2 minus 4 plus or minus the root of, that's going to be 16 minus 4. I got some work to do. This is x equals 3 plus or minus the root of 5 over 2. Or x is equal to minus 4 plus or minus 16 minus 4 is 12 over 2. Now there's not much I can do about the first one, but the second one I can actually simplify. The first one gives me 2 roots. The second one also gives me 2 roots, by the way. Just to be clear about it, I want to just simplify a little bit. Minus 4 plus or minus, there's a 4 and a 12. The square root of 4 is 2. And 4 times 3 would be 12. So 4 root 3. I'm sorry, yeah, 4 times 3. Root of 2 is, root of 4 is 2 over 2. And I can kind of like, maybe divide through. This looks pretty simple, right? Or, and I'll put a box in this now. You get minus 2 plus or minus the root of 3. Which, as expected, I got 4 solutions to that problem over there. And that's it. Thank you.